All right, welcome to Physics Video 7.9. We're going to be learning about series and parallel circuits. The objectives are here on the screen. You should be able to identify components of a circuit that are connected in series or parallel. And then you should understand how connecting components in series or parallel will affect the overall voltage, current, and resistance. And then same thing for and then finally, you should be able to calculate the equivalent voltage, current, and resistance for components connected in series or parallel. Okay, so there's basically two parts to this video. There's going to be a series part and a parallel part. They both have their own properties, so please make sure that you understand the difference between them and when to use which properties. All right, so here we go. So we've already seen a circuit with one resistor connected to a voltage source. That was in the last video, right? And so you have to have a voltage source and a resistor, right? Voltage, resistor. Okay. So there are two ways that multiple resistors can be connected to a single voltage source. All right. And those are series and parallel, which is where we're headed here. All right. All right. So here we go. Here are the two ways that you can connect multiple resistors to a single voltage source. Sorry, I paused the video there for a second. All right, here we go. So the first way is what's called series. All right, when you connect two items in series, basically what you're doing is you're connecting the two items end to end. All right, so here you can see we've got two resistors, right? And they're just connected end to end. So that what's going to happen is an electron is going to come out of our voltage source, and it's going to have to go through the first resistor and then through the second resistor to get through the circuit, okay? And that's kind of what defines a series circuit, is that every electron has to go through both resistors, all right? And what that means is every electron follows the same path, and so the current is going to be the same everywhere in the circuit. In other words, if you've got, say you've got 10 electrons coming out of the battery every second. Let me clean up my drawing here. So suppose that electrons are coming out of the battery, and 10 electrons come out of the battery every second. Well, what that means is, by the time they get to here, you're going to have 10 electrons passing that corner every second. 10 electrons are going to go through here every second. 10 electrons are going to go through here every second. 10 electrons are going to go through the first resistor every second. 10 electrons are going to go through the second resistor every second. 10 electrons are going to go through here every second, 10 here every second, 10 here every second. So the current is everywhere, the same everywhere in the circuit. Sorry, current is the same everywhere in the circuit. All right, so that's the first thing. The second thing is, since every electron has to go through both resistors, what happens is the battery is trying to push these electrons through. The battery is trying to push the electrons through, and it has to push each electron through both resistors. So the resistance that the battery experiences is actually just the sum of the two individual resistors. So in other words, if this is a 5 ohm resistor and this is a 10 ohm resistor, the battery is going to experience 15 ohms, okay, the two of them added up. All right, now this last part is a little bit confusing, and it's actually, the concept behind it is confusing. The application of it is very simple, all right? So here's the deal. Remember, your battery has a high electric potential and a low electric potential. All right. So let's suppose that this is a 9-volt battery. What that means is one side is going to have high volts and the other side is going to have low volts. So I've got, and I made up these numbers, 15 volts and 6 volts. Notice the difference between those is 9 volts. So this would be a 9-volt battery. Okay. So the idea is, as the electrons go through our circuit, they have to get from an electric potential of 15 volts down to an electric potential of 6 volts. Okay, and where that happens, where they step down, is as they go through the resistors. So what's going to happen is my electron is going to go through here. When it goes through the first resistor, it makes some of its drop. So it might go from 15 volts down to, I don't know, whatever, I'm just making up numbers here, maybe 10 volts. So it lost 5 of the volts going through this first one, and then it loses the last 4 volts going through the other one. All right, so anyway, long story short, I don't think I did a great job explaining that. Well, let me rewind. So you have to lose your electric potential. The electric potential has to get from 15 down to 6. Okay, so the idea is the electric potential here is 15 volts, 15 volts, 15 volts, 15 volts, 15 volts. And then you use some of the voltage to get through the resistor. So in this example, the first resistor used 5 of those volts, right? Because we went from 15 down to 10. So the first resistor used 5 of the volts, which means that the other resistor is going to use the other 4 volts, right? Which is how we got from 10 down to 6, okay? And so what you can see is the sum of the voltages of the two resistors equals the voltage of the battery, okay? So that is basically what this little paragraph here says, okay? It kind of sums it up here. The sum of the voltage drop in all the resistors is equal to the voltage of the battery, okay? So these 3 bullet points are summarized in equation form here. And ultimately, these are the 3 things that you need to know when dealing with series circuits, because those are the 3 things that you're going to use to solve problems. Okay, so here's what it says. The current's the same everywhere. Okay, the total current coming out of the battery is the same as the current going through resistor number 1, which is the same as the current going through resistor number 2. So the idea is you're going to number your resistors. This is going to be resistor number 1, resistor number 2, and then the battery kind of represents your total. Okay, assuming, yeah, I'm getting ahead of myself. Okay, cool. This is the resistance the battery experiences. The total resistance experienced equals the 2 resistors added up, and then your total voltage is the voltage each of the batteries uses, each of the resistors uses added up. Okay, so write those down. And I think at this point, probably the easiest way for you to see this is to actually use it. Okay, so I'm going to give you a problem. All right, so here's what problems on your homework are going to look like. All right, you're going to be given a circuit like this, and you're going to be given sort of the fixed values of some things. So the battery, I will always give you the voltage, and the resistors, I'll always give you the resistance of. All right, and so what your goal is we want to go through and we want to find V, I, R, and P for all of the elements in the circuit. Okay, we got to find our voltage, our current, our resistance, and our power. All right, and we're going to do that by using these 3 rules, and we can also use Ohm's law. All right, it says, remember, Ohm's law, V equals IR, applies to each individual component. So if we know 2 of the 3 values, if we know 2 of V, I, and R, then we can find the missing one. All right? And then at the end, once you've got V, I, and R, you can find the power just by multiplying your current and your voltage to get the power. So this is always your last step, is to go through and find your power. All right? So write that all down. Let's boom, boom. Get rid of that to give myself some more room. All right, and let's solve this. Okay, so the first thing that we know is that the current is the same everywhere, right? The current is the same everywhere, but that doesn't help me any because I don't know any of my currents. So let's move to our next rule. The next rule says the total resistance is the sum of the individual resistances. So that's going to be my first step. So step 1. My resistance total is equal to R1 plus R2, right? So for us, it's 12 ohms plus 6 ohms is 18 ohms. Okay? So that's that. Now, this voltage rule tells me that this voltage plus this voltage has to equal the total voltage, 9 volts. But the problem is it could be 2 plus 7 or 3 plus 6 or 1 plus 8 or whatever. So we're kind of stuck. So your general rule of thumb is this. Oops. After you use one of these sort of rules up here, you're always going to use Ohm's law. So our step 2 is going to be to use Ohm's law. Because notice, for our battery over here, we know the voltage and the resistance. So I can now find my current. So step 2, current is voltage over resistance. So my current is going to be 9 volts divided by 18 ohms is going to give me 0.5 amps. So that's the current total, right? Notice, to find the total current, I used the total voltage and the total resistance. Okay? So you have to use all the numbers from one component, in this case, total. All right? So now our third step is going to be, oh, look, all of the currents are the same. So if I know the current in the battery, that means half of an amp is coming out of the battery every second. That means my current through resistor number 1 is going to be half an amp. And my current through resistor number 2 is going to be half of an amp. Okay? And now, once again, I've used one of my rules. So now my next thing is I'm going to use Ohm's law again. So I can find my voltage. V equals IR. Right? So my voltage is going to be 0.5 amps times 12 ohms gives 6 volts. And over here, voltage equals I times R. So this is for number 1, and now we're doing number 2. So it's going to be 0.5 amps times 6 ohms gives 3 volts. Cool? So now I know V, I, and R for the battery. I know V, I, and R for resistor number 1. And I know V, I, and R for resistor number 2. All right? There we go. Problem solved. All right, don't forget to check your answers. There's 2 checks for every problem. Number 1, use the rule you haven't used. And then number 2, make sure that the individual component powers add up to the total power. Oops. All right, so let's go back for a minute. We haven't used, in this problem, we have not yet used the voltage rule, so we can check it. This is going to be my check. So voltage total. In this problem, our total voltage is 9 volts. That's got to equal my 2 individual ones added up. So our individual ones are 6 volts plus 3 volts. Oh, it works, because 3 plus 6 is 9. All right, and then your last step that you should do at some point is go through and find your powers. So P equals IV. So for the total, P equals IV, I'm just going to do 0.5 amps times 9 volts gives 4.5 watts. That's my total. And then the individual ones, I'm kind of running out of room here. My board is getting cluttered. Let's see, let's do this. P1, oh shoot, well, pretend that's purple. So current times voltage. So our current is the 0.5 amps. Our voltage is 6 volts. Multiply it, and you get 3 watts. 3 watts. Over here for number 2, it's current times voltage, 0.5 amps times 3 volts is 1.5 watts. And sure enough, they add up, right? P total equals P1 plus P2. This is my second check. My total power was 4.5 watts. That's the same as 3 watts for bulb number 1, resistor number 1, and 1.5 for number 2. Okay, so that's the deal there. So let's do this. Boom. Let's take a look at a circuit that does this. Okay, so here's that parallel circuit that we just talked about, right? Down here we've got our battery. It's 9 volts, right? Up here we've got our 2 resistors. Here's our 12 ohm resistor and our 6 ohm resistor. Okay, and you can see that if you watch any given point, the current is the same everywhere, right? Like, you know, mark a point and I guess kind of time how long it takes for the electrons to hit each point. All right, or better yet, I can use this. Let's actually use the current. So the current there is 0.5 amps. Current through the bulb up here is 0.5 amps. The current through this bulb is, oops, 0.5 amps. The current through the battery is, or coming out of the battery is 0.5 amps. All right, so the current's the same everywhere. All right, and then we can check the voltage. So the voltage of the battery itself, I'm going to put one side in front of it and one side behind it so we can find the difference. And notice it's 9 volts. Don't worry about the positives and negatives. All right. I actually have these backwards. It should be positive 9 volts, but whatever. So, and then if we do the two bulbs, you can see that the first one is 6 volts. Both of them together are 9 volts. The second one individually is 3 volts. So you've got 6 volts, 3 volts, adds up to 9 volts. All right. And the only reason that the battery itself says 0 ohms, this, if you can see that says 0 ohms, is just telling you that the battery itself doesn't provide any resistance, but it does experience a total of 18 ohms of resistance because 12 plus 6. Okay, so there you go. That is series circuits. This took way longer than I thought it was going to. Parallel goes quicker, I think. So let's try to muscle through this, all right? So here we go. Let me do this. Pause. No. Pause. Parallel. Erase. All right. Okay. So parallel circuits. Parallel circuits has its own set of rules. Drawing of a parallel circuit looks like this. So the electrons come out of the battery, and they get to here, and they have a choice. They can either go this way, or they can go that way. So unlike series, remember, in a series circuit, every electron goes through every resistor. Here, every electron only goes through one of the resistors. Okay? So because of that, the first one is the voltage one. It says the electric potential has to get from high to low. So if we go back to our example from before, if we've got 15 volts on this side and 6 volts over here, the electrons have to go from 15 to 6 here. So in other words, each resistor gets the same voltage as the battery. Okay, so all of our voltage is the same in each of the resistors as it is in the battery. All right, now, so that's the first rule. The second rule is since every electron only goes through one of the resistors, the current gets split. All right, so in other words, if, for example, 5 electrons come out of the battery in a second, that means 5 electrons are going to get to here every second. And what's going to happen is when they get to this junction, some of them, they choose. So you might get 2 of them going this way and 3 of them going that way. So your currents split up. So the current through here plus the current through here is equal to the current coming out of the battery. Okay? And then finally, this is sort of like, imagine trying to leave a grocery store, all right? If you've got just one lane open, it's going to be harder to get out, okay? By doing this, we're giving the electrons a choice. They can go through one of 2 lanes. So what that does is it makes it easier to get out of the store. There's less resistance overall, okay? So the last rule tells us that the total resistance the battery experiences is less than either of the individual ones, okay? So here are the rules written in math form. The resistance one is really intimidating. For now, we're just going to use that as our last step for our check. Okay? So the rules are the voltage of the battery is the same as the voltage of each of the resistors, sorry. The currents add up. And then there's this weird equation with resistance, and I'll show you how that one works. All right? So here's our circuit. Okay, so once again, we need to find V, I, R, and P for everything. Okay, so the nice thing is you're always going to know the voltage of your battery, and all of the voltages are the same. So step number 1 is to use this. The voltage total is the same. The voltage here has got to be 9 volts. The voltage here has got to be 9 volts. Okay, and remember, after you use one of your rules, your second step is to use Ohm's law. So I'm going to use Ohm's law to find the current, right? I know my voltage and my resistance. So here, my current is I equals V over R, right? So I'm going to have 9 over 6 is going to give me 1.5 amps. And down here, my current is going to be V over R, which is 9 over 12, which is what, 0.75 amps. So that's my step 2, is to find the currents. So I found the current in resistor number 2 and the current in resistor number 1. So now I can use my totals. remember, the totals have to add up. So my third step is, I know the current flowing through here and the current flowing through here, those are going to combine to give you the total for the battery. So my step 3 is this. My total current is just I1 plus I2. So what do we get? 0.75 amps plus 1.5 amps gives 2.25 amps. All right. And then finally, step 4 is find the resistance. So resistance is going to be V over I. So for us, step 4, R equals V over I. So it's 9 volts over 2.25 amps gives you 4 ohms. So the resistance the battery experiences is 4 ohms. Okay, we are almost done here. So our last step is going to be the check. So what you want to do is grab your calculator and see if this works. We've got 1 over 4, right? 1 over R total has to equal 1 over R1, which is 12, plus 1 over 6, which is R2. So use your calculator and add these up and see if it works. And it does, so check. And then your last and final step is to find all of your powers. So go around and do P equals IV for everything. Okay, so let's see, we need a new color. Purple, done. So what we're going to find is that for resistor number 2, the power is I times V. So 1.5 times 9 is what, 13.5 watts. For number 2, P equals IV. So 0.75 times 9, what is 3/4 of 9? So that gives you 6.75 watts. And then for the last one, P equals, oh my goodness, we're going back to the black one. P equals I times V. So 2.25 times 9 gives you 20.25 watts. And so then you can check. P total equals P1 plus P2. So our P total is 20.25. Shoot, this is 2.5 down here. That's got to equal 13.5 plus 6.75, which it does. Okay. So there you go. Let's take a look at the circuit. Okay, so look, here we've got a 9-volt battery. Remember, all of the voltages should be equal, right? So let's grab these guys and see what the voltage here is. So for this bottom bulb, the voltage is 9 volts, right? And if you do the top bulb, you're going to get the same thing, because all that's happening is, remember, your electric potential has to drop by 9 volts. And so either it does it by going through the bottom bulb or by the top bulb. All right, and then your currents, let's see if our currents worked out. We said that the total current was, what, 2.25, if I remember right? So the current coming out of the battery is, there it is, 2.25. Notice, when the electrons get to right here, whoa, that's not what I wanted to do. When the electrons get to right here, they have to make a choice. And some of them go right, some of them go straight. And so the current here, we said was 2.25. The current, some of the current goes that way, 0.75. Some of the current goes this way, 1.5. So your currents add up. All right, so there we go. And we already did the check. That was a lot of physics. I'm sorry, that was longer than I hoped it would be. Have a good day.